Glass. It's something we see every day. We touch it, we use it, but rarely do we stop to think, how is it actually made? From window panes to mobile screens, bottles, light bulbs, lab test tubes, even the windows of a spacecraft, it's all glass. But the question is, what exactly is glass? Is it a stone, sand, or some kind of melted metal? Actually, glass isn't fully solid, and it isn't fully liquid either. It's an amorphous solid, meaning a solid where the atoms aren't locked into a fixed pattern. Before we melt down the sand and uncover the secrets of the furnace, a quick request. If you enjoy exploring how our world is built, hit that subscribe button. It helps us create more documentaries like this. Now, let's start from scratch. Glass is born from sand. But not just any sand. To make glass, we need a specific type called silica sand. It contains silicon dioxide, SiO2. This is the true backbone of glass. But here's the catch. If you heat pure silica sand, it won't melt until about 1700 degrees Celsius. That kind of heat is too expensive and difficult for most factories to maintain. So we add a few special ingredients to the mix. First up, soda ash. The job of soda ash is to lower the melting point of the sand. It brings the temperature down from 1700 degrees Celsius to around 1100 or 1200 degrees Celsius. But there's a problem. Glass made with just soda ash is water-soluble, and nobody wants a window that dissolves in the rain. That's where the third ingredient comes in, limestone. Limestone adds durability and stops the glass from dissolving in water. So now we have our big three: silica sand, soda ash, and limestone. These are mixed in a precise ratio. We call this mixture the batch. Now, the real process begins. The batch is fed into a massive furnace. This isn't your average oven. It runs continuously, 24 hours a day, for years. The temperature inside is around 1400 to 1600 degrees Celsius. In this intense heat, the sand melts down. But it doesn't become glass instantly. First, it turns into a thick, sticky liquid known as molten glass. Inside this molten glass, there are tiny air bubbles trapped. If these bubbles stay, the glass will be weak. So the next stage is refining. Here, the molten glass is heated further, allowing the bubbles to rise to the surface and burst. Now the glass is clear, smooth, and consistent. Next comes shaping. This is where we decide what the glass will become: a window, a bottle, or a smartphone screen. If we're making flat glass, we use the float glass process. In this step, the molten glass is poured over a bath of liquid tin. Why tin? Because tin is heavy and glass floats right on top of it. Gravity does the work, spreading the glass out into a perfectly flat sheet. This is why modern glass is so incredibly smooth. Now, if we're making a bottle, the molten glass is dropped into a mold and air is blown into it. The glass expands to fit the shape of the mold. This is called blow molding. So the glass has its shape, but right now it's very fragile. If we cool it down immediately, the slightest shock will shatter it. That brings us to a crucial step: annealing. In annealing, the glass is cooled down very, very slowly. This process can take hours. Now the glass is strong. But some glass needs to be even stronger, like car windows or phone screens. For this, we use tempering. In tempering, the glass is heated to extreme temperatures and then rapidly cooled with blasts of air. This puts the outer layer into compression. The result? Glass that is 4 to 5 times stronger. And if it breaks, it crumbles into small chunks, not dangerous, sharp shards. Now, let's talk about special glass, like bulletproof glass. This isn't just one thick piece of glass, it's a sandwich of layers: glass, plastic, glass, plastic. When a bullet hits, each layer absorbs and dissipates the energy. Then there's laboratory glass, made of borosilicate. This stuff can handle high heat and harsh chemicals without cracking. But here's a question. Why is glass transparent? Basically, the atoms inside glass don't absorb light. They let the light pass straight through. But if we add certain metals to the mix, like iron, chromium, or cobalt, the glass becomes colored: green, blue, brown. That's why beer and soda bottles often have those distinct colors. Now, let's talk environment. Glass is 100% recyclable. You can melt it down again and again without losing quality. We call recycled glass cullet. Using cullet saves energy and reduces pollution. Yet, despite this, we throw away tons of glass that ends up in landfills. If we recycle glass, we reduce sand mining and save the environment. Today, glass isn't just a material, it is the foundation of modern technology. Solar panels, optical fibers, medical equipment, space missions, it's all glass. It's amazing how simple sand, combined with human ingenuity and fire, becomes something so incredible. That is the story of glass. A story that looks transparent, but is forged in science, hard work, and the fire of a furnace.